James Christian Pare.
Hi, I'm Kim Charazitsvara.
Hi, my name is Benjamin P. Atak.
Hi, I'm Peter Anne-Marie Angobin. Hi, my name is Desiree Day.
Hi everyone, I'm Alexis Kizia P. Bartolome.
Good day everyone! Our experiment for today is entitled The Swelling and Shrinking Violets. For this experiment, we're going to witness how osmosis happens. But before anything else, let me first define osmosis. Osmosis is a special type of diffusion applies in water and other solvents. In this process, the molecules of the solvent tends to pass through a semi-permeable membrane from less concentrated solution to a more concentrated solution, making both sides of the membrane equal to each other. In this experiment, our subject would be eggplants because I believe that every household can easily acquire this kind of vegetable. And without further ado, let's get started.
The materials we need for the experiment are 120 ml of water, eggplant, bottle container, plastic cups, iodized salt, timer, ruler, spoon and knife. Cut 16 total circular shaped eggplants, then each piece of the cutted eggplants are measured with the same diameter 1.15 inches. After preparing the necessary procedures for the eggplant, the solutions are prepared next by assembling 6 bottle containers. Each bottle is labeled from treatment 0 to treatment 5 according to each bottle assigned salt concentration. Then salt is measured through a measuring cup. For T0 bottle, no salt is added. T1 is assigned with 5 ml salt, T2 is assigned with 10 ml salt, T3 is assigned with 15 ml salt, T4 is assigned with 20 ml salt, and T5 is assigned with 25 ml salt. Each of these are placed in empty bottle containers. Afterwards, 6 120 ml of measured water are assigned to each bottle containers. After putting the 120 ml of water to each container, the solutions are mixed with a spoon. Each bottle of treatment is assigned with 3 circularly cut eggplant to increase reliability, then each assigned pieces of eggplant are placed on each of the bottles simultaneously. After that, set the timer to 30 minutes, then wait. Subsequently, after 30 minutes, the soaked eggplants are removed from its bottles using a spoon or a forceps. Then per each bottle, the 3 pieces of eggplants are measured for any difference in its size, squeezed to test the texture of each eggplant per bottle or treatment, and noted.
So the first goal of our experiment is to present the different mechanisms of water in different concentration by osmosis. Our group tried to demonstrate osmosis by using some cuts of eggplants, which represent the cell, and mixture of water and salt, which represent the blood, where the cells or the eggplants are freely suspended. By the end of our experiment, we can see that the texture and diameter of the eggplant varied. The eggplants that was immersed on more concentrated solution are softer and squishier, while the one immersed on lower concentration are firmer and harder. We also measured the diameter after soak for 30 minutes in different solution concentration. The starting diameter of each eggplant is 1.15 inches, and if we notice the negative sign on some values on the charts, this indicates whether the eggplant decreases or increases. We also calculate the average change in length by percentage, and the column shows that the values goes lower as the solution is more concentrated. The lower salt concentration increases the length of potatoes, meaning water has entered the eggplant by osmosis. And it also means that there is a higher water potential inside the solution compared to the eggplant. So with that, we have a hypotonic solution. However, at higher salt concentration, we have a decrease of eggplant length. This tells us that water potential is higher inside the eggplant, so water has left the eggplant by osmosis. And we can say that the solution is a hypertonic to the eggplant. On solution T1, we can notice that there is eggplant that has no change in length, meaning this is an isotonic solution, or water potential is same as the water and eggplant.